Hello. I am going to run through a quick from here to there, starting from a blank canvas in Fusion 360 and ending in G-code. I'm going to start by making a test square. It's one of the first things you should draw and cut when learning Fusion 360. So we're going to go into our sketch. I'm going to pick it on the XY plane to be located there. I'm going to pick a rectangle. I'm going to select a center point rectangle. I'm going to create a 2 and use the tab to move to the other dimension, 2-inch square. Now I'm going to hit C to bring up the circle tool, or I could also access it here. Start at the center, pull it out 1 inch. Now from here I'm going to hit E for extrude, turning this two-dimensional sketch by adding a thickness of the material I plan on cutting, in this case 14 gauge, to a 3-dimensional body. You can see here it's saying it's making a new body. Now this sketch has become a body. From here, we'll move from design workspace to the manufacturing workspace. And now in the manufacturing workspace, we'll make sure we're in the fabrication tab. We're going to go over to setup. Clicking setup will bring up the setup menu. Few things to note here is we have the body that we created. We have this golden shadow around the body, which is a representation of the material space we plan on using. And then the X, Y, Z, which is our origin on the work. So where 0 is on the workpiece, the starting point. So the first thing we want to do is move that stock point, or this 0 point, to the bottom left corner. I'm going to move the navigation so we're looking at the top. And this is how it would look sitting in front of the Pro. And we always go to the bottom left-hand corner. You can see we have a little bit of extra material on the edge, and that's because in mine I happen to put a default of adding an extra 1/4 inch around. In actuality, you'll end up with a bigger piece of material. This is just going to be your reference 0. In the post-processing tab, I like to add in a name, so we can do test square. And right below here, if there's any particular comment that you want in the G-code that you can watch later on or look later on the machine, this is where you would put it. I'm going to hit OK. Actually, I can edit this just by double-clicking this folder. And then I'm going to go back here and I will add a comment, and I'll put you can add a comment here, just so you'll see that in the G-code at the end when we go look at that. Now we have that set up. You can see it's been created over here. And from here we're going to move into the 2D profile. This is where all of our tool and cutting paths will be located. We're going to click that. It'll bring up the 2D profile menu. First thing in the 2D profile menu is the tool tab. We'll start by selecting a tool. So I always grab one from my local library. This is where you'll want to create and save new tools. So I have an example tool in here I'm going to use, the example 45 amp tool. Select. I'm assuming you already know how to go through the process of developing a tool. It shows the cutting speeds of that tool down here. Next we'll move into the geometry tab, and we'll simply pick this face and it'll select this entire contour automatically. Face contours, it says here. That's great. We'll move into the height tabs. We use the default according to Langmuir. Next, we go to the passes tab. I do like to reduce tolerance with artsy pieces. Sideways compensation is always left, except for when I usually do a test square. I like center in that case. Finishing overlap cuts past the end of your cut slightly, just to smooth out any irregularities. We are going to go to the next tab, which is linking. So this is paths, essentially. So the lead in entry is how that's going to lead in, and the lead into the piece. So it'll pierce off the material somewhere and then come on into it and then work its way around. We're not going to use any of the lead in, lead outs, or the pierce clearance, because we're going to be doing a kerf width test with this piece. Okay. Now let's develop this tool path, which the head comes straight down, pierces right directly on the center of the line, cuts all around the piece on the center of that line, moves up, goes down, cuts the outside piece right on the center of the line. Let's just take a look at that in the simulation. Turn down the music a little bit. Not inspection. Simulation, please. So in the simulation, it cuts that really fast. So it's cutting it right on the line. So the idea behind doing that on a kerf width test is because now if you measured the outside of that hole, the amount that that piece is small compared to 2 inches is going to be your kerf width. And if you measure the inside hole, the amount bigger than that hole is than 1 inch is going to be your kerf width. So you could check it in a few different ways and average it, and then input that into your tool library if you wanted really accurate kerf widths. Okay, let's exit the simulation. Now from here I have a pathway underneath the setup. So I originally created the setup, and now I created these paths. So from here I'm going to make sure that I have that setup selected in blue, and then I'm going to go up to the NC program, this little rectangle with the G on it, select it here. I'm going to make sure my post processor's in place. I have my test square. Let's see that it automatically pulled that comment forward. I could modify it here if I'd like. I'm just going to go with the general cut height, spring back, pierce delay, and cut height. I have a THC and or HSI and THC, so they're both selected. 1 inch retract height, how much it moves up in between cut areas. So I'm going to post this. Sure, yes. And now I'm going to view the G code down here at the bottom. And it's probably brought it up on some other my monitor. Yep. There we go. So here's the G code. Oh, and I can't zoom in on this one. That's too bad. Here, let's see. And you can see it shows what post-processor version it is, which is 1.6 for Autodesk Fusion. Here's that comment it added. You can add a comment here. This is relating to the origin 0. And then it just goes through all those test cuts. It's about 50 lines of code. Oh, it's exactly 50 lines of code. And that's it. All right, that was pretty basic walkover, but walkthrough. So we glossed over a few items there, but I think that's the gist of how the process goes. Thanks for watching.